I'm working for Telefonica O2 Germany, which is one of the 4 operators in Germany. My topic today is measuring end-to-end quality for mobile data. So the special focus of my talk today is how can we measure TCP throughput as the user may experience it. So the first slide is one of these paintings on traffic evolution. To be precise, it's more on evolution of quality demand, and it should mainly show 2 things. The first one is we see an increasing demand of quality. There are a lot of applications around waiting to be invoked as bandwidth is available for our customers. And secondly, we see an increasing differentiation of quality demands, though the more or less transparent bit pipe we have seen in the past starts to show some structure which is mainly due to different quality demands coming from different services. What is the general approach we are following here? It's the network-based approach. That means we are looking into the traffic stream observed in the network in order to find out something about what the client is doing, how is throughput and latency he is experiencing. And the advantage of this compared to a device-based method is clearly that we here have full network coverage and we also have real-time availability. But on the other hand, we are a little bit away from clients, so we have the challenge to draw some reliable conclusions out of our observations. So where to look at and which data are most useful to face this challenge? Clearly, we have to move up from the network-based protocols, which very detailed show the quality provided at the different parts of the network, up to the end-to-end protocols if we want to measure end-to-end quality. So typically, and this has been shown by many presentations so far, the best place here is the GN interface, mainly for 2 reasons. It's a central part of the network and also in between the GTP protocol, which also shows some information on network topology. To look a little bit more in detail into the application protocols, the end-to-end protocols, the most basic protocol we can look at is the TCP protocol. TCP protocol carries most of the traffic and also most of the applications that are used today within mobile internet. And as a first part, it is absolutely necessary to focus on the information you get from there. That is mainly throughput and round-trip time, and also packet retransmissions and service access. In the second step, then you may extend this, you may enrich the information by detail your KPIs, your KQIs regarding the different applications. In particular, this is very interesting in the case of video streaming. Also, as mentioned before, we have some information from the GTP protocol, also from DNS protocol regarding network topology, device type, location, internet access, radio access type, and so on. So now we are coming to a more technical part, but before we show into detail the problems and specific issues of TCP measurement, I would like to do one step back to show some characteristics, the main characteristics on the method itself. So it's mainly a 2-step method. First you have KPIs, which are obtained in real time, and once you get that, you can put it into a database and do some post-processing. And this may help you to complete your knowledge with additional information you don't find into your KPIs, because information can be seen to 100% and may be hidden at the endpoints, at the internet, at the server, and also at the client. So post-processing may help you to answer some open questions there. For example, if there are some server problems, you may aggregate traffic according to the server, and then you can correlate quality according to different places to different servers in the internet, and that may complete the picture. But the main issue you have to solve before to design your KPIs right. What you don't get within these KPIs there are at least a couple of issues. If you don't get them within your KPIs, you will never get it back in post-processing. And in the following, I would show you this by a small example. Now we are going to talk about throughput. So which kind of throughput are we interested in? We are interested in network-provided throughput. That means throughput that is provided by the network, that is limited by the network, not limited by applications or by the client. We are also looking for realistic download scenarios. It's not about peak throughputs measured for the duration of 1 or 2 seconds, but it's say download of a 2 megabyte file, for example. Why this is useful? It may be useful for strategic marketing, customer care, capacity engineering, traffic management, as an input trigger maybe, and also other possibilities. So the basic approach to measure throughput. Mainly the first step you may take is just measure the TCP connection time and the total volume of data that is transmitted, and then divide the data volume by the connection time. The problem is you may have several downloads per connection separated by some idle times, and this may clearly underestimate a real throughput, so your KPI may be much lower than the user experience really is. If you apply this to live network measurements, you may get figures about 20, 30, 40 kilobits per second, which is clearly too low for an HTTP network, at least in the network of Telefonica O2 Germany. You may approve this, and this is done by many solutions we have seen so far, by a sampling approach. So what you do is you divide into very short measurement periods of typically 1 second or half a second, and then you identify those intervals which do not carry any traffic. You filter that out, and you just take the remaining active time, and then you calculate throughput. It may be called active throughput. The question is, how reliable is this approach? So we checked this by a simple measurement. We used 20 stationary measurement probes. We have around all our network in Germany, 7.5 megabits per second maximum throughput, good or fairly good coverage placement, and the test case was a simple 2 megabyte HTTP download. And then we measured the throughput directly at the probe and also complementary within the network by using this sampling approach. And at the end, we compared both together, and the result you can see here. This is every point at this graph represents one measurement. The horizontal axis shows the probe measurement, that is the measurement, the throughput as it really is at the probe. And the vertical axis, that is the network-based measurement result. So if you have a perfect match of network-based measurement with real throughput as observed at the probe, you may find all points lying at this green, in this green area here. But what you see on the contrary is that most of the results differ considerably from reality. In particular, within the region of low throughput, where you naturally have the biggest problems, there the measurement tends to overestimate the real situation. So it would be interesting to find out about the reasons. The first reason is clearly this fixed time interval is not accurate enough. The real download time differs considerably. Therefore, you get, in general, an underestimation of throughput. But the overestimation cannot be explained with this. The overestimation is mainly due to the nature of these idle times. So there are some idle times, some periods, which really may correspond to downloads, separate downloads following each other, which HTTP 1.1, for example, HTTP uses persistent TCP connections, so there are many things going on sequentially within one TCP session. So this is ruled by the application. But there are other points, other cases, those idle times are coming from real network problems. That is mainly TCP timeout and buffering. And therefore you have to distinguish between both of them. And if you do that, you find a nearly perfect match with real experience. So this should be quite a short example to show you that measuring quality out of the network is not an out-of-the-box solution. You have to get experience with it. And you also have to improve the measurement methods. You have to be very careful what you measure, and you have to think about how to approach as far as possible towards the quality of experience. This all is a learning curve. It's a process, and the effectivity of this process severely depends on the quality of KPI design.